I just wanted to do a quick follow-up on this video that I did just the other day on the integral of x times arctan x dx that we have up here. The interesting thing that came up in the discussion after we did this was it had to do with our integration by parts and the idea that right here in this integration by parts, technically we could have some kind of constant right here, and we tend to ignore that, right? So I just wanted to go over what that's all about. This is a pretty new idea to me. I haven't really thought about this very much, but I just wanted to share my thoughts and give you my idea for how this thing works. So let me scroll down and we'll do some things on integration by parts. Okay, so we have our integration by parts formula, and rather than looking at like a specific example, we're just going to deal with this, the generic formula, and look at how we would do this. So generally, if we want to use integration by parts, what we'll do is we'll take our integral over here, and we'll break it into two parts. We'll call one part our u, and we're going to call our other part our dv. Of course, we'll differentiate our u part, and we'll get our du, just the derivative of u. But then the interesting part here is for dv, what we'll do is we'll integrate our dv, right? And we'll get our value for v that we need here. But what we'll do is we'll always exclude the plus c, because if we're doing an integral, we always have a plus c. So to me, the question's about like, why are we excluding this, and are we forgetting this? Do we need that plus c? Like, what's going on here? So what I'm going to do is let's just do our integration by parts formula, but let's include the v plus c now. And so instead of, for my integration by parts formula, I'm gonna actually change it, right? So instead of writing it like this up here, I'm gonna write it as u times v plus c. And then when we integrate, we're not going to just integrate v, we're going to integrate v plus c du. Okay, so doing this out, we're just going to distribute our u. We're going to have our uv plus uc. And then here, we'll just separate this into two integrals. We'll have our v du, and then we're going to have a minus c du. But we know this integral right here, integral of du, is just going to be u. So then putting that all together, if we rewrite this, we have our uv, we have our plus uc. I'll take this over here. This is actually uc. So you see we're subtracting our uc minus v du. And what happens is these cancel, and then we get back. So even if we use our constant here, we just still get back to the same integration by parts formula that we're used to. And so I think that tells us why we always just ignore the c, basically, is because we don't need it. We're gonna, if we included it, it's usually going to be more work, and we still get back to the same formula. Now, what came up in the video, and also there was a video from Dr. Peyam that we had a link, DHY linked to Dr. Peyam's video, and what Jan W brought up was that actually maybe including the plus c in some cases could save work, right? So we exclude it because it's more work, but we're saying let's leave the plus c in because it's going to actually save us a step. And that makes sense, because what you can do now, what we're saying is you're totally free to do this if you want, because it's not going to cause a problem, as the c is going to cancel out. And not only that, you can call it whatever you want, right? If I wanted to call when I'm integrating, if I want to call this like v plus 5 or v plus pi or 1, or in the example we did, it was 1/2. You can do that, and that's what Dr. Peyam's video was about, really, was that just create the c that you want, and then in some cases you'll have this nice cancellation. And then actually doing this, creating a conveniency, can actually save some time. Like if we go back to the problem that we did, where's the problem we did? So right here, if we made our c 1/2, then what would happen? Oh, if we made our c 1/2, then this is a half x squared plus 1. And then when we do our integral here, this x squared cancels with this x squared. So what we're saying is you can set up this plus c however you want, and if you can use to save yourself some work, then you can do it. You don't have to worry about it, because the plus c is not going to change the answer. So that's it. Just my quick little take on this. And again, I don't think I've ever actually used this myself. I did watch Dr. Peyam's video, I think, when it came out. So I had like some familiarity, some vague familiarity, but it's not something I've used. So I thought it was really interesting. That's it. We'll stop it there. Thanks for watching. Take care.